now let's take a shot at problem number 2. So I'm going to assume that you've read problem number 2 already, and that we know that it is dealing with 2 variables or 2 columns of data, one for McDonald's and one for high fructose corn syrup. I have already gone to the spreadsheet and I made a new tab called number 2, and I copied the McDonald's and the high fructose corn syrup columns in. All right, so now we need to figure out what kind of test we are running. If you look here, since it's 2-column data, it's either going to be one of these or it is going to be one of these. And the difference between the 2 sample proportion test and the chi-square test for independence is how many levels or categories you have for each of your variables. If you look at McDonald's, it only has 2 levels, no or yes. If you look at high fructose corn syrup, it only has 2 levels, no or yes. So since they both only have 2 levels, that means that we are going to be running a 2-proportion z-test. All right. So our population number 1 is going to be McDonald's, and our population number 2 is going to be not McDonald's. I am going to come over here and I am going to copy some of the formula stuff so that we've got it for reference. I'll move you over a little bit. Yeah. Right there. And I'm going to shrink you down to size. There we go. All right. All right. So what do we need? We need p hat 1, p hat 2. We need p hat c. I think the easiest way to do this is to highlight your data. Come on over to pivot table. I want to make a pivot table right on this sheet, and I'm going to do it, let's say, right here. Okay, there we go. Now, here you're going to need to listen a little bit. We want McDonald's to be the explanatory variable and high fructose corn syrup to be the response. And that's because we're looking at the 2 different levels of McDonald's, those that eat there and those that don't. So your rows are going to have to be McDonald's. Start with that. And then if we come down to values, we can do eat at McDonald's. And it breaks it down. Basically, we're almost 50-50 for who does and doesn't eat at McDonald's. Now, in the columns, we want the 2 different levels of high fructose corn syrup. So I'm going to choose columns, high fructose corn syrup. Now you can see, no, these people do not. Yes, these people do. All right, so we're going to build everything around that information right there. Cool. Keep that in mind. Hypotheses. So our null hypothesis is going to be that the proportion of the McDonald's people that are drinking soda and the proportion of the non-McDonald's people that drink soda is the same. Alternative hypothesis, the people that eat at McDonald's are more likely, greater than, to drink the soda than those that do not eat at McDonald's. Our alpha, once again, is going to be 0.05. This is a population survey, and we're going to need 3 pieces of information. We need p hat 1, p hat 2, and p hat c. We're going to get those 3 values from looking here. So p hat 1 is the McDonald's group. Let's see. These are the people that eat at McDonald's, the yes. So 23 out of those 35. This, oh, I don't like when you get in the way. 23 out of 35 drink the soda. So this will be 23 divided by 35. P hat 2 is going to be those that don't eat at McDonald's. So that's 12 out of 36. 12 divided by 36, boom. All right, so we can see pretty big difference between those proportions, right? 66% of us that eat at McDonald's drink the high fructose corn syrup sodas, and only a third of those that don't drink them. Okay, and so p hat c would be there were 35 people that said yes total out of 71. So there's the three proportions we're going to need to solve this problem. All right, moving forward, we now need to talk about sampling distribution, center, the spread, and the shape. Starting with the spread, for these, we're always looking at 0. That's like saying that the null hypothesis is that the difference between the two proportions is 0. And for the spread, you're going to use this formula right here. So that will be SQRT of P hat C times, and you have to put a multiplication in, 1 minus P hat C times 1 over, here's your first sample size, plus 1 over, here's your second sample size. Couple of parentheses, and there's our number for our spread. So pretty big spread. Our spread is almost 12%. For the shape, we want to know whether it's going to be normal or not, and we need to use these conditions right here, that the first sample size times are combined, and then first sample size 1 minus combined, and then same thing with the second sample size. All of those have to be 5. So here we go. I'm going to calculate those. So N1 times PC, N1 times 1 minus PC. Technically, those should have a hat on them. I'm not going to worry about it. N2 times PC, and N2 times 1 minus PC. And let's see what we get for those. First one would be 36 times this number. Okay, so we're good there. And then 36 times 1 minus this number. We're good there. And then 35 times this number. And 35 times 1 minus this number. Okay, and all of those are larger than 5, so our conclusion is going to be that the distribution is normal, okay, which is important. The p-value doesn't work unless it's normal. All right, so moving along. Next step is we need our z-score. Right, and recall that our z-score is equal to subtracting the two proportions and then dividing by the standard deviation. So I'm going to go, get out of the way. P hat 1 minus P hat 2 divided by our spread gives us a z-score of 2.728. That's pretty big, right? Now for our p-value, we are theorizing that the McDonald's people have a greater proportion, right? That's why up here we said greater than. So that means it is a right tail. Remember that for the right tail, we do 1 minus norm.s.dist of this number. Oh, right, you know what I need? I need an equal sign of this, which gives me a p-value of 0.003. Conclusion, reject the null hypothesis because our p-value is smaller than 0.05, our significance level. Conclusion, people who eat at McDonald's are more likely to drink fructose syrup soda than those that don't eat at McDonald's. And not a huge surprise, right? That if you're willing to put McDonald's into your body, what else you're willing to eat. But still cool to see that the results actually bore that